Yep, let's start it. In this session, we are going to start Apache Pig. So what is Apache Pig? First one, Apache Pig is a big data processing framework. Apache Pig is a big data processing framework. Big data processing framework. It is a data flow framework team. It is a data flow framework. Data flow framework means in Apache Pig there are different operators: load operator, store operator, for operator, conditional operators. Different operators are available. Data travel in a different operators, different flow. That's why we are calling it is a data flow framework. We will discuss what are different operators available, and we will discuss what is each operator purpose. So data travels in different operators in our Pig scripts. Okay, it is a data flow framework. It reduces lot of lengthy code thing. It reduces lot of lengthy code of MapReduce. Example, let's say you are writing MapReduce program. It may have mapper program and reducer program and a driver program, right? A MapReduce application may have mapper program, reducer program, driver program. Assume these three programs may contain around 50 to 60 lines of code. We can write the same implementation, means the same solution using Apache Pig, maximum of 4 to 5 lines of code. By using Apache, we can reduce a lot of lengthy of code team. How it will reduce lot of lengthy of code? While writing Pig scripts, you will clearly understand. And next one, it is easy to learn, easy to implement, because its syntax is very simple. Syntax is very simple. Syntax is very simple. Anyone can understand. Anyone can understand and can implement. So this Pig script is not only for developers team. A non-developer, non-programmer also easily learn, easily provide big data solution. Easily learn, easily implement, and easily provide for any big data solution. Okay. It was initially implemented by Yahoo. It was initially implemented by Yahoo company team for their internal projects. To provide big data solutions in a simple way, Yahoo developed this Pig framework team. Later, they donated to Apache. Later, Yahoo donated Pig to Apache. Apache is a largest community. It maintains open source projects team. It maintains lot of open source projects. Yahoo donated Pig to Apache to make Pig software available for everyone. Okay, so Apache Pig is a free and open source. Apache Pig is a free and open source. Open source. It is completely free. You can download and you can install. You can download and you can install. And if you want to modify, you can modify Pig software according to your requirement. It's completely free. Okay. Next one team. Pig has its own language. Its own language called PigLatin. PigLatin. Pig has its own language called PigLatin. So PigLatin is a scripting language. PigLatin is a scripting language team. PigLatin is a scripting language. So you may thinking again, is it look like Java or Python or Scala language? No team. PigLatin is a very simple, easy language team. PigLatin language is a very easy and simple language. Anyone can easily learn, anyone can easily implement, can understand, can implement PigLatin language. It is similar to SQL. It is similar to SQL. PigLatin is similar to SQL. So who has SQL knowledge, they can easily understand PigLatin language. Who does not have SQL language, they do not take much time to understand PigLatin language. It's a very easiest language. Okay. Understand, right? What is Pig team? Let's start team. Apache Pig installation. Apache Pig installation. So first important to note. Note 1. Hadoop should be installed. Hadoop should be installed and up and run. First important point. Second important point. Note 2. We need either root user or sudoer user. So we have two users in this system. User 1. In this mission, I have a user 1, name is root and password is C family. Whatever the VM I said, right, that has two users. User 2. Username is C family and password is C family. I have two users team. So I logged in as C family user. First I am starting Hadoop. Start -all.sh. I am starting Hadoop team. it is starting all daemons of Hadoop. Now let's test daemons are started or not. Data node is started, resource manager is started, node manager is started, secondary name node started, name node started. It means all daemons are started. Now let's open browser, check, open name node URL 192.168.255.152:9870. 9870 is a name node URL. Hadoop 3.x. In Hadoop 2.x 50070. Here utilities, browse file system. So this is my HDFS file system. So Hadoop is up and running. Okay. Now next one team. Steps to install Apache Pig. Steps to install Apache Pig. Step 1, download latest version. Download latest version. Step 2, install Apache Pig. Install Apache Pig. Step 3, set pig_home and path variable. Okay. Step 4, verify pig is installed or not. Pig is installed or not type. Okay, first step, downloading latest version of Pig. Okay, so this one, let's say team, first we enter into cd/opt directory, and here we use sudo wget command and URL of Pig software. How to find URL of Pig software? Let's open Google. Type Apache mirrors, then click on first link. Click on this first link. Here, let's scroll down. So go to, these are different Apache products team. A to Z products are available. Go to P location. P. So here we see Pig. Click on this Pig. Here we see latest version is Pig 0.0.17. If you click on latest also, you will see 0.17. Okay. So latest version is 0.17. Here we see tar file. pig-0.17.o. This is SRC, source file, open source. We don't want source code, we want Pig software. So this is Pig software team. pig-0.17.o.tar.gz. Right click on this one. Here, copy link address. Okay. So paste that link address. So this is Pig download team. Let's go to opt directory in our Linux machine. ls. Here we have already some softwares are installed. Now let's download this one. Sudo wget, execute this command, enter password of C family user. It is started downloading team. Depends upon our internet speed. It will take few minutes time to download. Okay. So here size of this pig software is 220 MB. 220 MB. Depends upon our internet speed. It may take few minutes time. So once download is successful team, we are going to install Apache Pig. We are going to install Apache Pig. Installation is very easy team. Installation is very easy. So we use first step, extracting tar file. Extract tar file. Extract tar file. So we use sudo tar command, tar -xvzdef. Okay. So this is our tar file name. This is our tar file name. Okay. Once we extracted, second one, B. Rename. It is optional. So we rename by using mv command. So sudo mv, and instead of this lengthy name, pig-0.17.0, instead of this lengthy name, what we are going to take, we take short name pig. It is optional team. Third step, remove tar file. It is also optional. We use rm-rf start.gz file. We are removing. Next one, D. Very important thing. Change file permissions. It is very important. Very important. Okay. Very important, because our file is presented in opt directory. Our username is cfamily. So while executing, it may going to create log files. It may going to create some important files. So we need to give permissions, all permissions on pig installation directory. So I'm giving sudo chmod -R pig, along with internally pig contain different directories. For all directories, I'm giving 77 on pig directory. That's it. This is very important. Okay, let's wait to download team. Yep, downloaded successfully team. Now let's execute sudo tar -xvzdef and pig tar file name. Enter cfamily user password. So it is extracting team. ls. Here we have lengthy name. Let me sudo mv pig, this lengthy name to short name pig. Okay. Now sudo rm-rf start.gz ls. Now sudo chmod -R 777 on pig ls. If you observe, color change also, color code also changed. Yes or no? So now installation is successful team. Once installation is successful, now we will set up pig_home path variable. Now we are going to set up pig_home path variable. Let's go to pig installation path, cd pig ls. Observe, pig installation path contain different directories and different files. Yes or no? One is bin directory, and important directories, bin directory, scripts directory, configuration directory. These are very, very important directories. Let's go to cd bin ls. Here we have a pig command and pig.py Python script. Okay, so to make this pig command available anywhere, first one, pig installation path is this one, pig underscore home, pig underscore home equal to pig underscore home equal to slash opt slash pig. It contain, it has different directories, and files. Important directories bin. Important directories bin. It has pig command. Next one, configuration. Conf directory. It contains different configuration files. Configuration files. So to make all these available, we are setting pig underscore home path variable type. Okay. So we are going to do two steps of setting path pig underscore home and path variable type. First one, we are going to set this pig underscore home and path variable and pig class path. Here we use Hadoop underscore home and Hadoop path type because pig requires Hadoop path. On top of Hadoop only we are running pig. That's why we are using pig underscore class path equal to Hadoop path. Then once this path is set, we restart bash RC file. Okay, first one, let's execute this one. Let's scroll down. So let's scroll down here. Let's enter pig path team. So I'm setting pig related path. As means comment team pig path. Okay. So let's scroll down. Control X Y. Save and quit from nano prompt. Let's restart this one. Let's restart this bash RC file because bash RC file executes when user is logged in. So user is already logged in, right? Whatever the configuration we set in bash RC file to reflect this terminal, we are restarting bash RC file team. So successfully restarted now. So download is completed, installation is completed, configuration is completed. Now let's verify pig is installed or not. Pig is installed or not. Set him. Here there is a command called pig. So when we type pig, it will start pig team. When you type pig, it will start pig software. So when you type pig, it will start pig. Instead of that one, we are going to use pig space hyphen version. Let me execute him. Pig space hyphen version. See. So Apache Pig version is 0.0.17. Yes or no? It was released in 2017. After that, there are no updates. Last update is 2017. Okay. So that's it for pig installation team. Pig installation. Let's start team. How to start pig? Once pig installation is completed, we will start pig. So first important to note, Hadoop should be up and run. Hadoop should be up and run, up and run. First important to note. Next one, we can start Pig in two modes. We can start Pig in two modes. Pig in two modes of team. They are one local mode, and second one HDFS mode. Okay, so local mode. So in local mode, Pig reads local file system. Pig reads local file system. Local file system means operating system file system. Operating system file system team. File system. In local mode, it will read local file system. How do we start local mode? Use pig space -local. Let me start him. So clear the screen. Pig space -local. Press enter. Okay. 1 minute team. 1 minute. Pig options. 1 minute. Pig options. -L. 1 minute. Yep. Pig -x local. So pig space -x local team. It will start Hadoop in local mode. It will open grunt cell. It will open grunt cell team. Grunt cell. So it will opens grunt cell. Pig-x starts a pig in local mode. Okay. So let me write quit. So quit is a command to quit from pig prompt. Next one team. Next one HDFS mode team. HDFS mode. Second one HDFS mode. HDFS mode. Sorry team. 1 minute. By default, pig opens HDFS mode. Pig opens HDFS mode team. Default mode is HDFS mode. Next important one. In this mode, it reads HDFS files. HDFS file system. HDFS file system team. So we can start HDFS mode using pig command. Just you can enter pig. Okay, let's see pig. It will start HDFS mode team. So this is HDFS mode, and other one duplicate tab I am opening. Clear the screen. Okay, let's type pig space -x space local. It will start pig in HDFS mode. Sorry, local mode. So here we are seeing grunt cell. Yes or no? Either local mode, or HDFS mode, local mode or HDFS mode. Pig opens grunt cell. Pig open grunt cell. How Linux has bash cell, corn cell, Pig has its own cell called grunt cell. Grunt cell understands only grunt cell understands only HDFS, Pig commands string. It will understand only Pig commands or Pig scripts It will understand only Pig commands and Pig scripts. Grunt cell understands only Pig commands or Pig scripts. Okay. Yep. We started Pig in local mode. So Pig space -x local. Here I want to load local file system into Pig environment team. One more important point, we can execute any Linux command. We can execute Linux command in a grunt cell. So here I want to load local file. I want to know what are local files presented in my system. ls command. Here we have different local files. There is one local file called comment. I want to load this comment file. So first I want to know what is the content presented in this local file. I'm executing Linux command cat comment. So it contains 4 rows. Yes or no? So we are executing Linux commands in a grunt cell. We are executing Linux commands. We can execute few commands team, not all commands. ls command, and we executed cat comment file. So it is displayed 4 rows of this file. So we find local file system data. I want to load this local file system. I want to load this local file system thing in my grunt cell or Pig environment. I want to load this local file. Let's see team. I'm loading comment file. Comment equal to load. File name is comment. Okay. Load comment file as column names. Column name is I want to give lines colon char array. Setting this file contain number of lines, right? Number of lines. This file contain number of lines. Number of lines, 4 lines. Each line is a character data, right? That's why I'm defining data type is char array. Each line so here comment file contain multiple lines. Each line is a character data. So to store character data in Pig, we have a char array. How languages contain string? In Pig, we have a data type called char array to store each line of data. Okay. So first I created one line. I created lines. So I loaded file. So this is we loaded file team. We loaded file. Once we loaded file, right? Once we loaded file, if you want to see the content here, let's understand. Here, comment. Left side you are seeing, right? Comment. Before equal to, you are seeing, right? Comment is a relation, is a relation. So right side load operator, it reads this comment from local file system and loads into relation. This is relation. So this load operator creates a bag. It creates a bag. In that bag, it loads all the data of your local file system, and that bag is pointed by comment. If you want to see the output, team, we execute command saying dump comment. Let's execute. Dump is an operator. It will display output. You can execute grunt, and you can execute dump comment. So this comment operator, here dump. This dump command execute comment relation and displays output on a console. It executes relation and displays output on a console. It executes relation and displays output on a console team. If you observe, see, we got output. Each line is one tuple. So collection of tuples is a bag. Tuple represents in parenthesis, right? Understand, right, team? How to load local file into Pig environment. Yep, let's see example in HDFS mode. Pig in HDFS mode. I said when you type a pig, it will start by default in HDFS mode. So I want to list files in HDFS file system. ls command. When I type ls command in previous example, we opened pig in local mode. It displayed what? It displayed local file system files. When you type ls, yep. So when you press ls now, it will read HDFS file system data team. ls. We are getting IO, yeah. ls command is local Linux operating system command. If you want to display, we need to execute what? Hadoop commands. Like Hadoop fs -ls root directory. So you cannot execute Hadoop commands directly in a grunt shell. You can execute only Linux commands. Grunt shell will not allow to execute Hadoop commands. So if you want to see Hadoop, in our system we have Hadoop 2.x. In Hadoop 2.x, what is the IP address of name node team? 192.168.225.115.50070. 50070 is a name node port number. So remember team, first one, name node URL. So IP address colon 50070 in Hadoop 2.x. Hadoop 2.x IP address colon 9870 in Hadoop 3.x Hadoop 3.x team. So we have Hadoop 2.x, right? 50070. Let me check whether port number is enabled or not. Let me open duplicate tab. Yep, let me execute enabling port team. Enable port in CentOS. Click on this one. Let me enable port number. Five double zero 50070. Yep, let's use sudo. Five double zero 70 is already enabled. Let me check JPS. So name node is already running. Let's check IP space ADDR space show. So IP address is 192.168.225.30. 225.30. So it is name node URL. Yes or no? So name node is already accessible. So in this name node, utilities browse file system under C family, under data directory, we have EMP file. First, let's load local file. So first one setting. First, let's put local file into HDFS file system. HDFS file system. Okay. So here I'm using Hadoop command. Hadoop fs -put comment file into under root under C family under data directory. So we are placing local file comment. Let's take one more. We have comment.txt also, right? Let's say cat comment.txt. So this file also contains 4 rows. Okay, no problem. We have already placed comment file, right? So first one, we placed our local file into HDFS file system. This is HDFS file system. Now load HDFS file into Pig environment. So we are loading local file into pig environment team. So we are using go to pig here. Let's say com or c equal to load. Where is our file? Under root, under C family, under data directory, we have a comment file. Let me go to name node URL, refresh. So we have a comment file. We are loading this comment file under C family, under data directory. We have a comment file. We are loading this comment file too. We are loading this comment file as column name team. I am giving lines colon data type. I am assigning char array. Okay. So once we load, I am executing dump command to display content of this relation. Comment of this relation. Press enter. You will see output in a console. You will see output in a console team. Let's wait. Observe. I said every pig command internally converted to MapReduce application. We are not writing. We are writing simple statements. We are writing simple statements to execute. But these statements are internally converted to what? MapReduce programs. Yep. So we got output, right? Yes or no? So this is our output. Let's understand pig terminology. In pig, while writing pig scripts or pig commands, we use these four important terminologies: relation, bag, tuple, field. In pig scripts, we use four important terminologies: relation, bag, tuple, field. Relation, bag, tuple, field. First one, field. In RDBMS, we call it as a column. In RDBMS, we call it as a column. Employee number column, employee name column, salary column, gender column, age column, city column, etc. If it is a employee table. In RDBMS, we call a column. Column contain that column data, right? If it is employee number column, it contain employee number data. Salary column contains salary column data. Gender column contains gender column data. Simply, field is a data entity. It is a piece of data of a record. Okay. It is like column in RDBMS. It is like a column in RDBMS. First important terminology, field. Okay. Each one we call it as a field. Next important one, team. Next important one, tuple. Tuple is a collection of fields. Tuple is a collection of fields. Tuple is a collection of fields. It is similar to row in a RDBMS table. RDBMS table. A row is a collection of columns, right? A row is a collection of columns, right? Similar way, a tuple is a collection of fields, nothing but collection of columns. Collection of columns team. Example, this one, 101, comma, Srinivas, comma, salary of Srinivas, gender of Srinivas, department number of Srinivas. So one row is a tuple. Next one, 1 minute, someone asking question. Yeah, nested bag, friend, nested bag. We can say nested bag. Uh, 1 minute. I came to hometown. Two minutes, 1 minute. Yeah. Let's start. In this session, we are going to discuss PigLatin operators. In PigLatin language, in PigLatin language, there are 24 operators. There are 24 operators. Learning PigLatin language, nothing but learning these 24 operators. Learning PigLatin language, nothing but learning these 24 operators. If you understand these 24 operators, then PigLatin, you can write any PigLatin script to process big data. PigLatin language, they given 24 operators. If you observe these 24 operators, you can compare with SQL. Similar to SQL, they given 24 operators. So first one, loading data from local file system or HDFS file system into Pig environment. Then for each, to read each row, sample, reading sample data, limiting rows, filter operation. Dump means displaying data in a output console. Store means after processing where you want to store the data. Do you want to store HDFS file system? In which path? Describe, to display relation. What are columns presented? What is the data type of each column? Illustrate, sample data. If you want to see the sample data, we use sample and illustrate. Union operation, joins, left outer join, right outer join, full outer join, cross join, grouping operation, co-group operation, exec, run, pig, register, define, order by, distinct operator. Total 24 operators team. These are 24 important operators. In this 24 operators team, in this 24 operators, I said Load means loading data from local file system or HDFS file system. Foreach means reading each row of a bag. So here these 10 operators for regular operations, and other one to retrieve data from multiple relations. To retrieve data from multiple relations team. Multiple relations. Then we go for join operations. Joins. Join operation, left outer join, right outer join, full outer join, cross join. So joins are used to read data from multiple relations or multiple bags. How we use join operation in RDBMS? We have a join operation in Pig. Join, left outer join, right outer join, full outer join, cross join. For inner bag purpose, we have two operators: group operator, co-group operator. To execute Pig scripts, instead of writing individual commands, Pig commands, we can create a separate file. In that file, we can write a list of Pig commands. To call that a Pig script file, they given these three commands: exec, run, Pig. For UDF purpose, they given register define. And here I'm giving brief intro about UDF. UDF stands for user defined functions thing. User defined functions. User defined functions. See, if these 24 operators if these 24 operators not sufficient to provide complete solution of big data, assume these 24 operators not sufficient to provide solution for big data. Assume these 24 operators not sufficient to provide big data solution. Then we can write our own user defined functions. We can write our own user defined functions using either Java or Python. We can implement in other language also. Most of the time we implement user defined functions either in Java or Python. Then we attach that function to script, Pig script. Then we can solve any problem and we can provide solution for using Pig scripts, Pig operators plus UDF. You can provide a solution for any problem type. That's the main advantage of UDF. So for after writing UDF, how can you attach UDF to Pig scripts? First we register UDF using register operator. Then for that register operator, we can create our own operator using define. We can create our own name using define team. We will discuss clearly while implementing UDF operators. So order, we can arrange data in either ascending order, descending order. Then distinct to eliminate duplicates to display only unique values. So these are 24 operators. 24 operators. In this 24 operators, load purpose is loading local file or HDFS file into Pig environment. Once data is loaded, we want to read each row, right? For that one, we have for each operator. So instead of reading complete data, I want to display sample data. Then we go for sample operator. While displaying output in a console, I don't want to display complete rows. I want only one or two rows. Then we go for limit. Filter means inside data, I want to search particular value. We go for filter. Dump can be used to display output in a console. Store can be write data in a output console. These are different operators. We are going to discuss all these operators one by one practically. Learning PigLatin nothing but learning these 24 operators. 24 operators. Let's start understanding load operator. We understand Pig has 24 operators. In that, first important operator is load. So main purpose of load is to load local file or HDFS file, to load local file or HDFS file into Pig environment, to load local file or HDFS file into Pig environment. We use load operator thing. Okay, syntax. So first one, in a grunt cell, we use relation space equal to space load operator. Here we specify path of local file or HDFS file, path of local file or HDFS file using Pig storage, Here we specify delimiter. So there is a predefined function called Pig storage, and as here column names colon data type, column 1 name, data type, etc. Here we use column n name, column m name, data type. So we use different columns. Yep. So in this way, we load either local file or HDFS file into Pig environment. Okay. So here load operator, we use Pig storage function. Let's say team, let me take one example without a Pig storage, with a Pig storage. You will get a clear understanding. First example 1. So loading HDFS file, which has only one column in a row. Okay, loading HDFS file which has only one column in a row. We have a multiple rows, but column is only one. So here I have a comment file. So let me load in a Pig environment, clear screen. Setting, I am loading local comment file into relation. Now dump dump C. See team, comment file. Comment file has only one row. Hadoop fs-cat under root under C family. Under data directory, we have a comment file. So comment file, here I am taking this entire row as a one column, second entire row as a one column, third entire row one column, fourth entire row one column. If you observe here, so each column I am giving lines, data type is char array. So this entire row stores in one column. Okay, let me execute a dump. You will see output. So we are using this command. So first one, grunt cell. So we used C equal to load, and we loaded HDFS file system under root under C family data directory comment. As column name is lines colon char array. Okay, so we used grunt dump C. Dump C. So we got output here. We got output. This is first example. Example 2 team. Example 2. I have a HDFS file, EMP file. See team, I am creating one EMP file, cat greater than EMP local file. I am going to place this file into HDFS file system. So data, we have 4 records, Control D. I am placing this file into HDFS file system, Hadoop FS -put, and file name is EMP. I want to put this file into under C family under data directory. I am placing EMP file. Yep, I am placing this file into HDFS file system. Now team, I want to load this file. So first one, local file system team. Local file system we placed into example 2 file with multiple columns. File with multiple columns. Okay, so we have local file. We placed this local file into HDFS file system. Okay, step 1. Step 1, local file system. Step 2. So here I'm using command. Clear screen. I'm using load command team. Load command. Let me use load command. I'm loading into EMP relation. File name is EMP file. Okay. So this EMP file contain how many columns team? First one, employee number, employee name, salary, gender, department number. Okay. So I'm creating columns list here. Let's see. First column is EMP NO. Data type is integer. ename colon, data type is char array, comma, salary colon int, comma, gender colon char array, char array, comma, department number colon int. So I created a file. Is there any spelling team? Yeah. So spelling is char array. So spelling mistake. Ename char array. Gender char array. Here char array. Spelling mistake. Now it is working fine. Now let's execute dump emp relation. Dump emp. So first one, we are loading employee file, employee HDFS file into employee HDFS file into, let me take next line tip, employee file into pig environment. I'm using dump command. I'm using dump command to display emp relation data into console. Let's execute. Observe the output. Observe the output, and can anyone tell me why we got this error? We will get error thing. Yep. So we got, sorry, we won't get any error, but columns we got null. Yes or no? We have a four rows in EMP file. So we got four tuples in a bag, but in a four tuples, each field contain empty data. Why? Can anyone guess why we got error? So here the problem is previous example, we stored entire data in a single column, but here we have multiple columns. Yes or no? We have to give an indication to Pig saying divide file each row into multiple columns. If we not specify any delimiter, here default delimiter is tab space. Default delimiter is tab space. If you not specify any delimiter to read file data and to parse, it will take default delimiter is a tab space, but our file contain delimiter is comma. So what will happen, Tim? This entire thing taken as a first column. This entire thing is taken as a first column, and it is trying to store this entire thing in a first column. Employee number. Employee number is the integer type, but this is character because it contains including characters. That's why first column is empty. We did not specify any other columns. Other columns after this entire data, there is no other data. That's why other columns also it is stored empty. So while loading data into relation, we have to specify delimiter thing. To specify delimiter, we using pig storage function. Here we will specify delimiter. Delimiter of our file is comma. Okay. So here we use we will specify delimiter. First important point, important to note, if file has different delimiter, if file has different delimiter, we have to specify delimiter. We have to specify delimiter using pig storage function. Okay, so in this way we will specify in this way. emp equal to load HDFS file name using pig storage. Here we pass delimiter name. So if you not pass pig storage, default will take what? Tab space as a delimiter. Okay, now let's execute it. Now let's execute dump emp. So now we executed what? Dump emp. So now we are getting output properly. Let's wait. Now we are going to get output properly. So we got output properly. Yes or no? Yes or no, team? Yep. So now let's understand different operator. In this session, we are going to see loading sample data into multiple relations. I'm creating sample file in my local file system. I'm going to place this file into HDFS file system. So I'm creating sample file. This sample file contain 3 columns, 3 rows. 3 columns, 3 rows. Control D. Let's place this file into Hadoop. fs-put. File name is sample into root C family data directory. So we are putting sample file into data directory. Okay. So it is successfully placed. Now let's come to pig. We already opened this grunt cell in a HDFS mode. Yes or no? So we started in a HDFS mode. Okay. Now load this file. So here my requirement is I'm going to load this sample file into multiple relations. See, what is the delimiter of this file, team? What is the delimiter for each column? Here we have a tab space. Tab space, not space. Space means one single space. Here we have around 4 spaces between each value. So it is a tab space. So default delimiter in a pig is tab space. One important note I am writing. Default delimiter in Apache Pig is tab space. Default delimiter is tab space. So pig storage function is optional. No need to use pig storage function. If you use delimiter, we have to use what? Tab space. Okay. Let me load this file into HDFS file grunt cell. So S1 equal to load file name under root under C family under data directory. We have a stamp file. Using is optional as this file contains 3 columns: A colon int comma B colon int comma C colon int. So similar way, I am creating one more relation S2. Similar way, I am going to create one more relation S3. Dump S1. Dump S1. Observe team. Similar way, I am going to do dump S1, dump S2, dump S3. Example. So dump S1, dump S2, S3. Dump S1, S2, S3. S2, S3. We get output is same. Yes or no? We are loading. Yeah. Here 3 variables we created, right? So it will take first row, first value stores into A. Second value stores into B. Third value stores into C. Similar way, next row, it stores first value into A, B, C. A, B, C. Okay, let me execute dump S1. Yep, same. Dump S2. Dump S1, we got output, right? This is the output, S1. S2 also we get same output. S2 also you get same output. S3 also you will get same output. Understand this example, and continuation we are going to load same data into different relation and understand what will happen. So S2 also given same output. Now dump S3. Dump S3. S3, when you type dump S3 also it will give same output because in 3 relations a file is same and number of columns are same, number of rows are same, so we are getting output is same. So we got same. Now let's see team. I am creating one relation, S4 relation. S4 relation. Here I am using optionally using Pig storage is optional. Just for your understanding purpose, here I am going to use tab space C. Tab space as I am using only 2 columns setting. 2 columns. 2 columns. Can anyone tell me, is it creates a S4 relation or is it gives any error? Because file contain 3 columns. In each row, 3 columns, but we are assigning into 2 variables. Is it possible or not? Oh, sorry. Clear screen. Here, using give space. Press enter. Yep. One more important point. Here we have to use single quote. Single quote. Delimiter inside single quote. Now it is working fine. It is working fine. Okay. Dump S4. Dump S4. Guess what is the output? Guess what is the output? Can anyone guess what is the output? So we are using dump S4. Guess what is the output? So we taken only 2 columns, right? 2 columns. Our sample file contains 3 columns. So first column it stores in A, second column it will store in B. There is no other column. That's why it will ignore third column. And second row, first column value it will store in A, second column it will store in B, third column, to store third column there is no other variable. That's why it will ignore. And it will come to next row. First value it will store in first column, second value it will store in second column, it will ignore third value. So when you press dump S4, we get only 2 column values and all rows. Observe it. Yeah. So we got output, right? Yes, sir. Let me take another example. Let me take another example. Say, Tim, I'm taking S5, S5, S5 relation, load C family, sample data file. Using is optional. If you want, you can take using. Using is optional. And I'm taking A colon int, comma, B colon int, comma, C colon int, comma, D colon int, comma, E colon int. Can anyone guess? Is it executes or is it gives any error? If it executes, what is the values of or what are the values of D, E? Because our file contain only 3 columns. Yes or no? We do not have 5 columns, but we are creating 5 columns in S5 relation. So I am creating relation. This is our relation. So one of our friend guess for E and D, D and E columns contain null values or empty values. You are correct, friend. So dump S5, dump S5. Dump S5. So here in input file, we do not have fourth and fifth columns. So pig stores null values, null values null values in D comma E columns. D comma E columns. Okay. See the output thing. See D column, E column, it stores empty. Null means empty team. Empty values. So instead of say null, empty values. Okay. Observe, this is empty. D value, this is E value. D value, E value. D value, E value. In 3 rows, D and E, it stores empty, null. Okay. It Apache Pig will not give any error, even though your file contain less than your schema. Even though your file contain less than your schema, Apache Pig will not give any error. For more columns, it will store empty value string. Clear, right? Is it clear? Now let's understand dump operator team. Dump operator executes or evaluates relation and displays output on a console. Dump operator executes relation, displays output on a console. Okay. So syntax we use dump relation. Okay. Example relation 1 grunt cell relation 1 loaded file 1. Okay. Grunt 2 grunt cell relation 2 we filter data in a relation 1 we got a relation 2. Again grunt relation 3 equal to we applied some transformation on relation 2 we got a relation 3. Now I am executing grunt dump relation 3. When I execute to relation 3, so here we are using dump command. Before that, let me take this one entire thing. So we are executing dump relation 3. Relation 3 depends upon what? Relation 2. Relation 2 depends upon relation 1. Relation 1 depends upon load operator. Yes or no? So it will create first loading data into relation 1. Filter operation, we are getting relation 2. So let's say relation 1 depends upon load operation. Relation 2 depends upon relation 1. Relation 1. Relation 3 depends upon relation 2. Relation 2. So data is flowing from relation 1 to relation 1 to relation 2, relation 2 to relation 3. That's why we are calling Pig is a data flow language. Pig is a data flow language. So when I say dump relation 3, what will happen? It will prepare a MapReduce program for entire above flow. So loading file into relation 1, from relation 2 applying filter operation, getting relation 2, from relation 2 applying some transformation, getting relation 3, then displaying this one in a output console. So with this entire thing, it will prepare MapReduce. Whenever we execute dump command team, dump command, what it will do? It will display output on a console. To generate output, it needs this entire flow. This entire flow is converted as a MapReduce program. We are just writing 3 or 4 statements. These entire 4 statements internally converted to MapReduce program. We are not going to write that in. This is generated by Pig. Okay. Understand, right, team? So we are writing simple dump command. Here we are writing only one relation. Later we are going to write multiple relations. Depends upon our requirement. We may write multiple statements. One statement is load operation. One statement is filter operation. One statement is transformation operation. One statement is aggregation operation. And finally, we are going to execute dump, or one more command is store. We will discuss what is store. Dump command executes relation, displays output on a console. Okay, it simply displays output on a console. Example, we see dump emp. We got output. We got this output. Let's see. Let's wait. It is converting MapReduce program. Once MapReduce program is completed, we see output. So we got output. Now let's see team. One more operator, describe operator. Let's understand describe operator. It displays schema or structure of a relation. Relation means it displays column names and its data types of relation type. Relation. Let's execute describe. describe EMP, describe EMP. Let's say it. So EMP relation contain employee number column is int type, ename column char array type, sal column int type, gender column char array type, department number column int type. So describe command displays schema of a relation type. Let's start him. In this session, we are going to discuss for each operator. This operator can be used for so this operator can be used for navigating relation. We can perform below operations using for each operator for each operator. So we can perform first one. We can perform copying columns and rows into another relation, generating new columns or fields, and filtering fields. And next one, changing fields order. Next one, renaming fields. If you want to change any column names, we use for each operator. If you want to perform typecasting operation, we use this for each operator. And if you want to perform any transformation operations, we use for each operator. Let me take one simple, let me prepare input file for input data for this for each operation team. So here we are taking employee one file. So first I am creating cat emp1 emp1.csv file. So this is the data team. This is the data. So let me create this file emp1.csv file. Let's create this file team. Let's save. Let's copy this data. Control D. Now let's place this file into HDFS location. I am placing this file into HDFS location emp1.csv. So I am placing this file into HDFS file location. So we have input data. So first one, we have input data in HDFS file system. Okay. Now let's implement copy. What is copy? Inside for each, we have a copy option. So to copy one relation into another relation. To copy one relation into another relation, we use for each operator. Okay. Example. So let me go to Pig environment, clear the screen. First one thing. So I want to create a E1 equal to load. File name is under root under C family. Under data directory, we have emp1.csv file. Yes or no? We have emp1.csv file. Now using pig storage. Why we are using pig storage function? Because in emp1.csv file, data or columns data separated with delimiter comma. So we are using comma delimiter. As columns I am specifying empno colon int comma ename colon char array, okay, comma sal colon int comma tell me thing gender colon char array comma department number colon int. So first we are creating a relation. So E1 is successfully created. So describe E1. So E1 contain these columns. I want to create E2 relation. E2. I want to copy E1 relation into E2. I want to copy E1 relation into E2. For each EMP. 1 minute. For each E1, generate star. Star means all column setting. For each E1, generate a star. So dump, let's see, describe E2. Setting, same columns, right? So we are calling E1 relation schema and data into E2 using copy option. Let's say describe. Now let's click on dump E1. Run dump E1. We get the same data. Grunt dump E2. We get the same data. Here star means all columns. Here star means all columns. If you want only few columns, we use different approach to. Here we are copying all columns of E1 relation, all columns and all rows of E1 relation into E2 relation. We are simply copying dump E1. We get the same data. Dump E2 also we get the same data. So to copy one relation, all columns and all rows, we are using foreach operator. Yep. So we are getting 7 records. Okay, similar way, E2 also we get the same records. Dump E1 we are getting same records. Dump E2 also we are going to get the same records. Observe the output team. So we got same records, right? So understand, right, what is copying? We are using for each operator for copying one relation into another relation. Okay. So next one, generating new fields team. For generating new fields also, we use for each operator for generating new fields. See, I want to calculate HRA. I want to calculate HRA and total, or I want to calculate total. So for that one, HRA, we want to give 2% on salary. Tax, I want to calculate 2% on salary. Then finally, net salary, I want to calculate. I want to add HRA to salary. Okay. And I want to deduct tax from total salary, and I want to find net salary. So I want to create new columns like one is HRA, second one tax, third one total salary, fourth one net salary. I want to calculate these 4 new additional columns. So team, so I'm taking EMP sal, EMP details equal to foreach E1 generate. When I say star, it gives only all columns of E1. So instead of giving that one, I'm giving EMP envo, comma, ename, comma, salary, comma, gender, comma, department number, comma, I want to calculate HRA. So we are using column names sal into 0.2 means 20% as HRA, comma, sal into 0.5% as tax, comma, total salary I want to find. Let's say first, let me calculate these columns. So EMP details contain only these columns. So describe EMP details. See, so EMP details contain employee number, employee name, salary column, gender column, department number column, HRA column, tax column. Yes or no? So we calculated new columns. First important one, we calculated new columns. We calculated new columns. So we calculated new columns. One is HRA column. Another column is tax column. Yes or no? So by default it will take double data type for these new columns team. So for new columns, if you observe, for new columns it is taken double. So if you perform any calculation, by default it will take double column. Let me execute a dump of EMP details. Dump EMP details team. Observe output. So dump EMP details. Observe the output. So calculated values, we can see output. Observing, we see output of calculated values. So we calculated HRA become 5,200 and 13,000 become tax. For 26,000, 5,200 become what? HRA. This is 50% team. 0.5 means 50%. 50% tax become 13,000. Okay. So we calculated HRA, we calculated tax. I want to generate new columns team, new columns again. Total salary I want to generate, net salary I want to generate. So total salary equal to what? Total salary equal to salary plus HRA. Net salary equal to total salary minus tax, right? So same relation, EMP details. You can create another relation, EMP details. You can create a new relation, or you can take the same relation, EMP details equal to, for each EMP details, for each EMP details, generate EMP NO, comma, ename, comma, salary, comma, gender, comma, department number, comma, next one, HRA, comma, tax, comma, sal plus HRA as total sal, comma, sal plus HRA minus tax as net salary, So we calculated new columns. Then dump EMP details team. Dump, first describe columns, describe EMP details. We are going to see new columns. New columns are total salary, net salary. Yes or no? We are seeing new columns. Next one, let's click on dump EMP details. Dump EMP details, we get calculated values. Let me execute dump EMP details. Okay, we are going to see outputting. Let's wait. So this is output. Outputting. Okay. Now team. Now let's understand changing fields order. Filtering fields. Next important one. Let's understand filtering fields. Okay, let's see it. Filtering fields. Let's see it. Filtering fields. So I want only employee number, employee salary. Okay, employee salary. Next, I want HRA, tax, total salary, and net salary. I want only few columns. So first one thing, describe EMP details. Next one, EMP sal details. EMP sal details equal to for each EMP details generate EMP NO. I want EMP NO salary. I want to salary and HRA. I want to tax. I want to total. I want total sal, comma. I want to net sal. Okay. So describe EMP sal details. EMP sal details. EMP sal details contain column names. 1 minute, spelling mistake. EMP sal detail. Oh, we missed L thing. So see, employee number, salary, HRA, tax, total salary, net salary. Now let's dump EMP sal detail. See the output. See the output team. So we got only employee number, salary of employee, number, salary of employee. Next one, first one employee number, salary, HRA, tax, total salary, and next one net salary. Okay. So we filter only required columns. Yep. Let's continue for each operators team. For each operator. So we understand copy option, and we understand generating new fields. We understand filtering fields. Now let's understand change fields order. See, first one, let's describe EMP details relation. So EMP details relation contain employee number, employee name, salary, gender, department number. Next one, HRA, tax, total, net sal. So our requirement is changing fields order. So my fields order, I want to create a new relation. So EMP details 2. In this, first I want to generate fields order for each EMP details. For each EMP details, generate. First I want to EMP-NO, ename, EMP-NO, ename. Next I want to gender. Okay. Next I want to department number. After that I want to salary. After salary I want to HRA. After HRA I want to tax. After tax I want total salary. Total sal. After total salary I want to net salary. Understanding. So I'm changing fields order of existed relation. So previous relation, this is previous relation. Then I'm displaying dump EMP details 2. Let me copy this one. Let's execute. So we are changing fields order. So let's execute to describe EMP details 2. You will get fields order. EMP details 2. So this is the output team. If you observe, we got first employee number, right? Next employee name, gender, department number, now salary, now HRA, now tax. Tax we change it to 1.10%. This is total salary. This is net salary. Okay. So we changed the fields order. Let me describe EMP details 2. See the fields order. So describe function displays complete schema of your relation. So whatever the schema order, then same way we get output. Understand, right? How to change the fields order, team? Now let's understand renaming fields. So my requirement is I want to rename fields. See, I have these names. Let me take describe EMP details 2. Okay. So if you observe, first I have a employee number. Next I have employee name. Next I have gender. Gender I want to change it to gender. I want to change column name is sex. And next one, sal I want to change it to salary. And next one, HRA, tax, total sal. So total sal I want to change it to total underscore salary. Net sal I want to change it to net underscore salary. So in this way I want to change the column names, field names. So here let me write for each command. So EMP details 3 equal to EMP details 3 equal to for each EMP details 2. for each EMP details to generate first one EMP NO, next one ename, next one gender, next one department number, next one sal as salary. I want to rename it sal as salary, comma, next one HRA, next one tax, next one we have total sal as total underscore salary, comma, net sal as net underscore salary. We are renaming fields team. We are renaming fields. Now describe EMP details 3. See, column names are changed, right? Net salary, total salary. Oh, gender also we want to change, right? Yep, no problem. Salary we changed. So instead of gender, we think that we need to change gender equal to sex. So now dump EMP details 3. EMP details 3. So output wise, we cannot see any difference, but only schema column names we changed. Yes or no? Schema column names we changed it. Okay, output we get the same output. Instead of gender, here use gender as sex. Then we get gender column name is going to replace as sex. Okay. So everything is same. Everything is same. So let me rename. EMP details to. Let me rename gender as sex. Okay. So clear the screen. So we understand how to rename fields. Yes or no? We understand how to rename fields. Next very important operation using foreach is typecasting. Very important thing. Understand when we go for typecasting. See, if you observe, salary column, okay, salary column integer values. If you observe HRA, it is double. Understand data type? HRA data type is double. Tax data type is double. Total salary data type is double. Net salary data type is double. So output also you are seeing numeric value, real numbers or fractional part values. Yes or no? Double values. So sometimes in output screen, people not interested to see the double values. People wants only numeric values. They don't want to see fractional part. So we want to change data type. We want to convert double data type to integer data type. That is our requirement. So to perform typecasting, we are going to use, let me say, for each EMP details 4, for each EMP details 4, okay, for first EMP details 4, for each EMP details 3, generate employee number, employee name, and here in EMP details we have a column name is sex, and department number we have salary column. Is salary column giving numeric values? Yes. Let me check previous output. Is salary column giving? So before that, first let me execute dump EMP details 3, because we changed salary column equal to sal column as salary column. We did not calculate it. We just renamed. If you rename, it will not change data type. When you apply any calculations, then only by default for every calculation Pig takes as double data type, because calculations may going to give fractional part values. That's why Pig by default it will assign for any calculation columns, it will assign double data type. Salary column is numeric only. So let's clear the screen. Let's change the data type thing. First one. So we are taking relation EMP details 4. EMP details 4. For each EMP details 3. For each EMP details 3, generate employee number, employee name. So we have gender column, sex column, and we have department number. We have a salary column, and HRA I want to typecast to integer, just to mention data type inside a parenthesis. Before column name, mention just data type thing. Tax I want to convert to integer type, and total salary. This total salary also I want to convert to integer type. Next one, net salary also I want to convert to integer type. Net salary also I want to convert to integer type. Press enter. Okay. So describe EMP details 3. Understand data types of EMP details 3. So some columns we have a double data type. Let's describe EMP details 4. See, salary column is converted to int, net salary converted to int, total salary converted to int, tax converted to int, HRA converted to int. Yes or no? Now dump EMP details 4. Okay, let me copy all these things. Let's execute. Let's paste and modify according to our requirement. See output. See the output thing. In output, we are seeing output values all are in numeric. There is no fractional part. Yes or no? So we can typecast any column data type to any data type as your required data type. As business says, convert a particular column into particular data type. We can convert any column from any data type to any data type using typecasting option team. Let's say team, very important operation in foreach, transformation. So my requirement is I want to give grades to employee. I want to give grades to employee. Employee salary greater than 20,000, I want to give A grade. Employee salary greater than or equal to 14,000, I want to give B grade. Employee salary greater than or equal to 9,000, I want to give grade is C grade. Otherwise, for other salaries, I want to give grade is D grade. Okay. So for this one, we use ternary operator. Here, ternary operator. Ternary operator team. Ternary operator. So we have condition, 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 question mark, result 1, colon, result 2, result 2. So first we write a condition. If condition is satisfied, we are going to return result 1. If condition is false, we are going to return result 2. So this is ternary operator. We are going to use ternary operator. Okay. Let's see team. Clear screen. EMP grades. EMP grades equal to for each EMP details for each EMP details generate EMP NO comma ename comma sal comma okay sal comma now I want to give grade thing sal comma grade. Let's see. So inside a bracketing I am writing sal greater than or equal to 20,000. Sal greater than or equal to 20,000. Question mark A grade salary greater than or equal to 20,000 A grade colon again inside result if this condition is not satisfied, it comes to colon, right? Again I am writing bracket, inside bracket I am writing sal greater than or equal to 14,000 question mark B grade colon again bracket start, inside this one I am writing sal greater than or equal to 9,000 question mark C grade colon again we no need to write any condition for any other values, give a D grade, yes or no? So close first this bracket, second this bracket, and third this bracket. As we are calculating values, right? as give a column name grade, that setting emp grades. If you observe here, if you observe our data, if you observe first employee we get A grade, second employee we get A grade, third employee we get B grade. No. So first condition, let's go here. Let's go according to this condition. First salary 26,000. 26,000 greater than 20,000. So first employee we get A grade. Second employee also greater than or equal to 20,000. We get A grade. Coming to third employee, 13,000. 13,000 greater than 20,000? No, it comes here. 13,000 greater than 14,000? No. 13,000 greater than 9,000? Yes. So for third employee, we get C grade. 8,000 greater than 20? No. 8,000 greater than 14? No. 8,000 greater than 9,000? No. Then this person we get a D grade. Fifth person we get a D grade. But sixth person we get C grade. Sixth person we get A grade. Okay. Let's see it. Let me execute describe emp grades. Okay, now dump emp grades. Let's copy this one. Let's execute. See the output thing. Yep. Observe outputs. So first employee A grade, second employee A grade, third employee C grade, fourth employee D grade, fifth employee D grade, sixth employee C grade, seventh employee A grade. Understand right? How we transform our data into required form? Yes or no? We transform our data into required form. Okay. Let's starting. Now let's understand store operator. It is used to execute relation. It is used to execute relation and output we can store in specified location. Dump operator executes relation, displays output on a console. Yes or no? Dump operator executes relation, displays output on a console. But store operator executes relation, writes output into specified location thing. Okay. So previous example, we calculated employee grades. Previous one, employee details for we calculated HRA, tax and total salary, net salary. We converted into required form. I want to store EMP details for. I want to store EMP grades into HDFS file system thing. HDFS file system. then we can go for store operator. After calculation completed, instead of displaying output using dump in a console, we want to persist the results into my required location. Right now we are persisting in where? HDFS file system. Okay. Setting syntax store relation into file path. Let me store our relations. So first relation emp details 4. Okay. So describe emp details 4. Next, describe emp grades. Okay. Now store emp details 4 into where I want to store under root under C family. Okay. Under data directory, give a name. I want to store it as emp details. Just I am giving file name. Observe team. What will happen? Observe. Before that, let's copy and let's enter here. Example, let's enter it. So here we are storing the data. We are storing the data. After storing, what will happen? Observing. If you observe emp details 4 output, it is giving comma separation. Yes or no? Comma separation. So output also you will see same. If you want to change any of delimiter, you can change it in. First, after storing the output, you can open new tab. I am opening new tab. Let's enter C family user password. Okay. Clear the screen. Okay. Now let's wait. Store is completed. Now I am executing team. I am executing Hadoop fs -cat under root under C family under data directory. We save emp details, right? Our file name is emp details. Observe the output team. Emp details is a directory name. Let's see ls because it is a MapReduce program, right? Pig store command internally convert to MapReduce program. It is created underscore success file and part -m -5 zeros. So let's use cat command emp details / part -m -5 zeros string 5 zeros. Press enter. See the output. In output, we are seeing tab space. In output, we are seeing tab space. Are you observing thing? How it is storing data? 1 minute. How it is storing the data? Why it is storing tab space between different columns? Can anyone guess? Team, can anyone guess why it is storing? I said one important point. Default delimiter of pig is a tab space. Yes or no? Default delimiter of a pig is tab space. We want different delimiter in output also. Then use pig storage function. Use pig storage function. Understand, team? Did you understand? So use pig storage. So the default delimiter is tab space. Tab space. If you want to change default delimiter to required delimiter, use pig storage function. Let me execute this command, team. Here, output file, I want to change delimiter is comma. Let's execute in a pig. Let's execute this command. So while writing store emp details 4 into emp details 2 file using pig storage comma. That's it, team. Clear the screen. So first one, let's execute ls command emp details 2. Once this command is completed, let's execute that command. So map reduce is converted, 50% is completed, 100% is completed. Now let's go execute emp details 2. So it created underscore success part hyphen m hyphen 5 zeros. Underscore success means pig successfully written output into this directory. Part hyphen m hyphen 5 zeros means pig generated mapper program. That mapper program successfully written file part hyphen m hyphen 500 files. Okay. Now let's execute cat command emp details 2. This time delimiter is comma. Observe, delimiter is comma. Previous delimiter is what? Tab space. This time delimiter is what? Comma separation thing. Okay. Let's start it. In this we are going to discuss illustrate operator. Illustrate operator executes relation and returns some sample data type. And while executing, it gives entire hierarchy of the flow. Hierarchy of the flow means emp details 4 depends upon emp details 3 or 2, and it depends upon E1 file, etc. Okay, let me write illustrate. Clear screen. Illustrate. Illustrate. First one, illustrate. Relation name emp details 4. emp details 4. Press execute. See, it is given some sample data. Yes or no? So first one E1, it depends upon E1. Next one emp details. Yes or no? Next, EMP details is changed. Finally, EMP details 2. From EMP details 2, we created EMP details 3. From EMP details 3, we created EMP details 4. Understand right thing? It is giving sample data with entire hierarchy. EMP details 4 is created from EMP details 3. EMP3 details 3 created from EMP details 2. EMP2 details created from EMP details. EMP details again created from EMP details. EMP details created from E1 relation. This gives entire hierarchy. Entire hierarchy. Each hierarchy it is given some sample data. Some sample data. Understand right thing? Illustrate can be used for debugging purpose. You written multiple statements. You written multiple statements. You want to know before performing store operation or before performing dump operation, you want to know hierarchy of your relation. Then execute illustrate. Clear? Next important operator is sample. I don't want to complete data. I want to test with some sample data. Let's say I want to test with 20% of data. So before performing any operation on particular data, let's say E1 loaded from emp.csv file, emp1.csv file, right? emp1.csv file. Before applying operations on E1 relation, I want to test whether it contain our required inputs or not. See, E1 may contain huge volumes of data. E1 is created from emp1.csv file. Assume emp1.csv file contain terabytes of data. So after applying all operations, we are thinking that this emp1.csv file does not have our required input. No use of performing all the operations, right? So before going to apply all operations, we want to test with some sample data. We want to display in a console. Then finally we can compare and we can see. So sample operator we can give with the sample percentage. S equal to we have to give spaces to relation space equal to space sample E1 0.2 means 20% data. Now describe yes, you will see same column names. Dump yes, it gives output with a sample 20% of data. So instead of executing 100% of data, what we are doing, we are taking 20% or how much percentage you want, you can take and execute that sample data, because Apache Pig deals with huge volumes of data. We are reading HDFS file. That file may contain GBs of data, that file may contain TBs of data, that file may contain petabytes of data, we don't know. So instead of loading entire file into our processing, we test some sample data, we see output in a console, then we decide Yes, it contains employee number, employee name, salary, gender, department number. So by seeing this sample data, I'm thinking I have a required data. Then you can proceed. So this is for just for testing purpose team. Testing your data has valid data or not. Okay. Clear, right team? Yes team. So this sample takes random data team. Random data. It's not from beginning, it's not from end, it's not from middle. We don't know. It will take random data. Random data from 5. Okay. Yep. Now let's understand limit operator. Yep. Next important operator, limit operator. So we are using dump. We are displaying output on a console. Yes or no? We are using dump command. We are displaying output of relation in a console. While displaying output on a console, I don't want all records. I want only few records. Then you can use limit. So use limit command team. Say li equal to limit emp details limit emp details for I want to limit only 3 records. Dump first describe li. Li has a same schema of emp details for dump li. Then we get output is only 3 records. We get only 3 records too. Let's see the output. So we got only 3 records. We got only 3 records. Next important operator is filter team. To fetch only matching records based on some criteria. Criteria means condition. To get records based on some condition, we use filter operator. So let's say in this filter operator, in this filter operation, we are getting only female records team. Only female records. Let's see. I want to print only female records. EMP details, sorry. EMP details for describe female and dump female. We are going to get only female records. Filter the records team. Example 1. Let's see the output team. We are going to see only female records. So we are getting all female records. Yes or no? Next one, female records with high salary. So whose salary greater than 20,000? I want only female salary stream. with greater than 20,000. Filter EMP details. EMP details for gender equal to female and salary equal to greater than 20,000. So describe this female high salary, dump with this female high salary. Let's take this one, see the output. So we get only whose female salary greater than 20,000. Can anyone tell me greater than or equal to, right? We given greater than or equal to. 1 minute. So we are checking greater than or equal to 20,000. Only one employee. This employee salary, 2 employees. One is Swati, another one is Akim. These 2 employee salaries are greater than or equal to 20,000. So we get only 2 records. Yes or no? So we got only 2 records. Let me copy. So in this way, we can filter records. We can filter record stream. Order by operator. Order operator can be used to arrange our output data either in ascending order or descending order. This is one of the important operator thing. One of the important operator. So to sort the data either in ascending order, descending order, we are going to use order operator. Let me display employee names. Based on employee names, I want to display data in ascending order. Okay, employee names in ascending order. Clear screen. Let's see. Describe EMP ascending order. Let's see the schema. How many columns this one has? Same schema only, but we get employee names in ascending order. First, let's see employee names. So we have S, Srinivas, Swati, Padri, Meena, Vasu, Alia, Akim. So first we get Akim. Next we get Alia. Next we are going to get Badri. Next we are going to get Meena. Next we are going to get Srinivas. Next to Swati. Next to Vasu. Okay. So in this way we are going to get output. Let's execute this one. So dump EMP ascending order. Let's see team. Let's see output. Let's see the output. So we got output, right? Whatever we discussed based on the names, data arranged in ascending order. Yes or no? Next example team. So here based on salary I want to descending. Means I want to display high salaries to low salaries. Requirement is high salaries to low salaries. High salaries to low salaries. Yep. This is the example. Clear screen. DESC, describe. Describe. EMP sal descending order. Dump EMP sal descending order. So based on the salaries, high salaries to low salaries, we are going to get. Let's observe output T. And parallelly try one more example. Write pig statements. Write pig statements to find top three salaries. Parallelly write this query. I'm asking any one of you write and send me in chat box. Write pig statements to find top three salaries. So generally we take first statement, loading file. So let's say this one, loading file. This is already presented, just I'm writing steps for this one. First step. Second step, salary descending order. Yes or no? Salary descending order. Let's say here top three. So let's say order EMP sal order equal to order E1 sal. Column name is sal descending order. Next one, tell me top three equal to EMP sal order limit EMP sal order 3. Yes or no? So we got output of previous query. Top three, top salaries in ascending order. This is output for previous query. Let me copy. So we got 26, 25, 20, 13, 10, 8, 6. Yes or no? So top three salaries. Previous one only. So top three equal to limit EMP salary 3. Yes or no? Dump top 3. Yeah, we got top 3 employees salaries. These are top 3 employees. Yes or no? So 26, 25, 20,000. Top 3 employees. Right? Understand, right, team? Let's start, team. In this session, we are going to discuss union operation. Union means merging 2 or more relations. 2 or more relations. Merging 2 or more relations. 2 or more relations. So we can load multiple relations into Pig environment. Means we can load multiple files into Pig environment. Then we can merge all these relations into single relation. Then you can write or you can apply any Pig transformations or any Pig operations stream. So we have multiple files in HDFS file system. Multiple files in HDFS file system. We want to merge all these files as a single. Observe, I have these files. Let me create all these files in my local file system. Let me create a local file system and place it into HDFS file system team. So what I'm doing, I'm creating EMP1. First one, I'm creating EMP1. I'm creating EMP1. So in this EMP1, we have this data. We have 8 records. We have 8 records team. Control X or Control D. Control D to save and come out from this file. Next one, I'm creating one more file, cat emp2. In this file, I have 4 records. I have 4 records too. Control D. Next one, I have emp3. I have another file. In this file, I have 2 records. I have 2 records. I'm placing this file into HDFS file system. I'm placing all these files into HDFS file system. Hadoop fs-put file name emp1 under root under C family under data directory. I'm placing emp2 into data directory. emp3 into data directory. So total 3 files I placed into HDFS file system. From Pig environment to team, you can use cat under root under C family under data directory. We have a emp1. You can execute cat command team. When you type cat command, it is connecting HDFS file system, displaying the content. emp2, emp3. So these are different HDFS file system. Okay. So we have 3 files, employee 1, employee 2, employee 3. Observe data. In emp1, we have employee number, employee name, employee salary, gender of employee, department of employee. Okay. So EMP1, EMP1, we have EMP1 file, we have EMPNO, ename, salary, gender, department number. Okay, let's check EMP2. EMP2 file, EMP2 file team, EMP2 file, we have employee number, employee name, employee number, employee name, and salary, gender, department number. Okay, so EMP2 also has a same structure. EMP2 also having same structure. Coming to EMP3, employee number, employee name, department number, gender, salary. Order is different to him. EMP3, order is different. EMP3, instead of salary, we have department number. Instead of department number, we have salary. If you merge these three data sets, what will happen? If you merge three data sets as a single data set or single relation, so while calculation, we may get wrong outputs. That's why third data set or third relation, we have to arrange the fields in a required order. Yes or no? So let's first one, let's load EMP file. Let's load EMP1 file into EMP1 relation. Let's load EMP1 into EMP1 relation. So we got error. EMPNO into ename char array. Okay. Syntax error. Let me check this one too. So first one, e number, ename, char array, e cell. Let's remove sal, int, gender char array. Okay, same. Char array. Next one, let's change char array. And okay, let's take this one once again. EMP1. So we are creating EMP1. Okay, same thing. Ename gender, ename char array, gender char array. Yep. So now let's load EMP1. Let's load EMP2. Let's load EMP3. Let's load EMP2. Let's load EMP3. So we created three arrays, three relations. Describe EMP1, describe EMP2, describe EMP3. So only EMP3 fields order is different. EMP3 fields order, in the place of department number, we have a salary. In the place of salary, we have a department number in EMP3. But EMP1, EMP2 relations are same. So change fields order of EMP3 before merging, change fields order. So I'm writing here. I'm writing important note. I'm writing important note. Before merging, change fields order of EMP3 relation, because EMP3 relation fields order is different. So we are using EMP3 for each same relation. You can take different relation, you can take same relation. For each EMP3, generate employee number, employee name, salary, gender, department number, and final result also we are assigning in same relation. Now describe EMP3. See, now EMP3 relation contain employee number, employee name, salary, gender, department number. So same as employee 1, employee 2 relation. Now you can implement a merging operation team. So merging is very, very easy. Just we can use what? E equal to union, E employee 1, employee 2, employee 3, you can use any number of relations. So it will merge, first it will merge employee 1 data into E relation. After ending of employee 1, it will merge employee 2. After ending of employee 2, it will merge employee 3. So like that it will merge it in. Whatever the order we specify in union operation, the same order it will merge. Now dump E. See the output. So instead of displaying in a console, you can save this one into HDFS location using store. Understand? It is merged all records in a single file, single relation. Then if you want to store, you can store it. So this pig operator, pig union is equivalent to SQL union all. It allows duplicate stream. So in big data, remember one important point to team. In big data, we need duplicates also. Data is required. Based on our requirement, we can write a processing logic. Then based on that processing logic, we store the results. So big data duplicates also required thing. We can filter based on our processing logic. Okay. So that's why if you see many big data frameworks, union all is implemented. There is no separate union operation. Union means union all here. Okay. Understand right team? Union operation. Now let's understand distinct operator team. Distinct operator means distinct operator eliminates duplicates. It will return only unique values. It return only unique values. If you observe previous example, in previous example we performed union operation. Yes or no? We performed union operation. Let's see. After performing union operation of employee 1, employee 2, employee 3 relation, we got this data. If you observe employee numbers, 101 repeated how many times? 1, 2, 3 times, 3, 4 times, 5 times it. 102 repeated how many times? 103 repeated how many times? 104, 105, we don't know. So we want to eliminate duplicates. We want to display only unique values. In that case, we go for distinct operator. So let's say if I use this distinct, what will happen? Observe. E equal to distinct E. E equal to distinct E. Is it compares only employee numbers? Is it compare entire tuple with another tuple? Guess it. Is it compare only employee number? Is it compare entire tuple with other tuple? It will compare one tuple with another tuple thing, not only particular field, not only particular column. Here it will compare one tuple with other tuple. 101 we know 26,000 male 11. Is there any record with the same tuple values? Compare here. 101 Janaki 10,000 female 12. This record is different from this record. Here coming to another one, 101 we know 26 male 11. This is duplicated. 101 we know 26,000 M 11. This is duplicated. 101 we know 26 M 11. This is duplicated. So these three are eliminated. These three are going to eliminate. Let's say it E equal to distinct E. Same relation we are applying distinct E and we are assigning into same relation. Dump E. Before that, let's store this result into previous one. Yeah. Okay, let's go. Let's execute this one team. Dump E. Observe the output. How many 101 we know records are there? 4, right? So we have to get only one record. Yes or no? Entire tuple compared with other tuple presented in same relation, not particular field. observing, we got only 1101 record. Yes or no? 101 we no record, not 101. 101 we have 2 records. Yes or no? See, it is printing and it is matching entire tuple with other tuple. Yes or no? Before that we have this entire data. Let me copy. This is our E relation, right? Before applying, we have this data in a E relation, right? Grunt dump E. If you print this one, we have this one. After applying, we got this data after applying distinct. So here 101 we have multiple. Let's say I want to print employee data only distinct department numbers. Department numbers I have 12, 11, 12, 11, 12, 11, 13, 12, 13, 15, 20. I want only unique department numbers. When I use this one, it is not displaying particular unique department. So if you want only unique department, then we have to generate a separate department team. Sorry, separate relation with only department numbers. Then unique departments we are finding. Unique department numbers we are finding. DNO. Then dump DNO. If you want a particular field, if you want only particular field team, you have to filter only particular department, particular field, then apply distinct operation. Then you will get unique values of particular field. Understand, right? Yep, we got only unique records. Okay, so that's it for distinct operator. Now let's understand distinct operator team. Distinct operator means distinct operator eliminates duplicates. It will return only unique values. If you observe previous example, in previous example we performed union operation. Yes or no? We performed union operation. Let's see. After performing union operation of employee 1, employee 2, employee 3 relation, we got this data. If you observe employee numbers, 101 repeated how many times? 1, 2, 3 times, 3, 4 times, 5 times it is. 102 repeated how many times? 103 repeated how many times? 104, 105, we don't know. So we want to eliminate duplicates, we want to display only unique values. In that case, we go for distinct operator. So let's say if I use this distinct, what will happen? Observe. E equal to distinct E. E equal to distinct E. Is it compares only employee numbers? Is it compare entire tuple with another tuple? Guess it. Is it compare only employee number? Is it compare entire tuple with other tuple? It will compare one tuple with another tuple thing, not only particular field, not only particular column. Here it will compare one tuple with other tuple. 101 we know 26,000 male 11. Is there any record with the same tuple values? Compare here. 101 Janaki 10,000 female 12. This record is different from this record. Here coming to another one, 101 we know 26 male 11. This is duplicated. 101 we know 26,000 M 11. This is duplicated. 101 we know 26 M 11. This is duplicated. So these three are eliminated. These three are going to eliminate. Let's say it E equal to distinct E. Same relation we are applying distinct E and we are assigning into same relation. Dump E. Before that, let's store this result into previous one. Yeah. Okay, let's go. Let's execute this one team. Dump E. Observe the output. How many 101 we know records are there? 4, right? So we have to get only one record. Yes or no? Entire tuple compared with other tuple presented in same relation, not particular field. Observing, we got only 101 record. Yes or no? 101 we know record, not 101. 101 we have 2 records. Yes or no? See, it is printing and it is matching entire tuple with other tuple. Yes or no? Before that we have this entire data. Let me copy. This is our E relation, right? Before applying we have this data in a E relation, right? Grunt dump E. If you print this one, we have this one. After applying, we got this data after applying distinct. So here 101 we have multiple. Let's say I want to print employee data only distinct department numbers. Department numbers I have 12, 11, 12, 11, 12, 11, 13, 12, 13, 15, 20. I want only unique department numbers. When I use this one, it is not displaying particular unique department. So if you want only unique department, then we have to generate a separate department team. Sorry, separate relation with only department numbers. Then unique departments we are finding. Unique department numbers we are finding. DNO. Then dump DNO. If you want a particular field, if you want only particular field team, you have to filter only particular department, particular field, then apply distinct operation. Then you will get unique values of particular field. Understand, right? Yep, we got only unique records. Okay, so that's it for distinct operator. Yep, in this session we are going to discuss aggregations. When we say aggregations we have sum aggregation, right? Min aggregation, max aggregation, right? Count aggregation, right? Next, average aggregation. So these are 5 important aggregations: sum, min, max, count, average. I want to find aggregations. First, I am loading emp1.csv file into emp relation. So I return this query. So I loaded. I am trying to apply aggregation operation. Result equal to, for each emp, generate sum of salary as total. I am trying to apply this one. Let me execute this one. It is given error. Observe error. org.apache.tools.grunt. Error is 1045. This is error number. It is giving line 10, column 26. could not infer matching function for sum. How? It is giving an error. Why? Why it is giving an error? Can anyone guess why it is giving error? What is for loop? For each. What is for each? Tell me, Tim. What is for each? For each reads one tuple. Yes or no? Each time it will iterate one tuple. How many tuples we have? Let's print this one. Cat emp1.csv file. How many tuples we have? 7 tuples. Yes or no? We have 7 tuples. But each time it is iterating how many tuples? For each one tuple. Sum requires entire salary column values, right? Is for each operator giving all column values at a time? No. Yes or no? For each operator not giving all columns at all values of salary column. At a time it is giving only one column value. So this for each operator repeats how many times? 7 times. That's why we got an error. We got an error. Here if you observe, we got an error. How can we resolve? Did you remember one important point while discussing different operators in Pig terminology? In Pig terminology, bag is a collection of tuples. We have inner bag. What is inner bag? Inner bag placed as a field in outer bag. Inner bag placed as a field in outer bag. I said one more important point. Inner bags used at aggregations. Did you remember, Tim? Inner bags are used in aggregation time. See? So we have to convert this all tuples as a inner record, inner bag. So we are getting error because of aggregation should be applied on only inner bags. When we group the data, inner bag will be produced. So first we perform inner bag. So first performing column aggregations. First we are going to perform column aggregations. All tuples. In this, all tuples we are converting as a one group. So for each EMP, generate salary. First I am taking only salaries. Only salaries. Then from these salaries, I am creating group. So group name, sal group. Let's say group name is sal group. First, let's create a all salaries. First read only all salaries. Okay. Then create a group, create a salary group, describe sal group. So this is salary group. Salary group contain first column name is group. Okay. Salary group name, and another field inner bag is created. Are you observing thing? Inner bag is created. Let's see, copy this one, and now display salary group. Display salary group in a console. You will get a clear understanding. all salaries are converted as a inner group team, inner bag. Once inner bag is created, you can apply some operation or any aggregation operation. Yes or no? Group name is all and inner bag. This is inner bag. Did you understand it? So it is created salary group. All salaries are converted as a inner bag. Yes or no? Now let's implement aggregation operation. For each GRP salary group, generate sum of sal colon sal, because column name here we use sal colon sal as a total. Observe T. So for each salary group means we have only one tuple. So for each command reads one tuple. Generate sum of salary colon salary. So column name is sal. So this tuple, this inner bag name is sal. In this we are reading sal colon sal means each individual tuple in a inner bag. So these all tuple values are passed to sum function. Then sum reads all salaries, performs aggregation, returns a result. That result name we are giving total. Yep. See error symbol at near sal. Yeah, let's say sorry team. Here we have to use sal.sal, not colon, sal.sal. Now it is working. So dump or sum. We are reading salary reference dot this salary column. Yep, we got total salary. This is the output of result. Understand writing? So we understand all aggregations. Now let's perform all aggregations. I want to perform sum operation, average operation, max operation, min operation, count operation. So here I am using here sal group, sal.sal, 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 sal.sal. Okay, here let me remove this one. Let me Okay, let me copy this one. Let's execute. Applying all aggregations on a salary column. Okay, now let me. Oh, here we got error team. So we are going to get error. Okay, Max also. Let's check team. So all are correct now, right? Let me copy this one. Let's execute here. Clear screen. Let's execute. So now we find all operations successfully. Average we applied, max we applied, sum we applied, min we applied, count we applied. So all aggregations we applied. Yes or no? So now dump all or all. See the output, which is maximum value, which is minimum salary, average salary we are finding, number of salaries we are finding, total sum of salaries we are finding. Yeah. So these are results. These are results. So if you want to typecast, you can typecast, because most of the people are interested to see numeric values. First one is total salary. Second one is average salary. Third one is max salary. Fourth one is min salary. Fifth one is count. Yes or no? So this is our output, right? Now let's understand. My requirement is find the total salaries gender wise. Female, what is the total salary? Total salaries. And male, total salaries. Total salaries. Female total salaries, male total salaries I want to find. For this one team, we use grouping aggregations team. Grouping aggregations. Let's observe team. So first one, we are reading. Previous example, we read only salaries. In this, we are reading gender as well as salary. So we are creating one relation. Then we are creating group based on gender. So previous group is all, but this time group is gender. Okay. So let's see. Clear screen. We are reading gender. Yeah, sorry. Clear screen. So here we have to give spaces between relation team. Okay. So don't forget to give spaces equal to relation and equal to and statement. We have to give space. And I'm creating gender group. I'm creating gender group. Then I'm printing gender group. Observe the output. Two records we see. One is male record, another one is female inner bag. We see male bag, we see female bag. Two bags. In outer bag, we see two inner bags. One inner bag is female related, one inner bag is male related. So female, group name is female, all female records. Group name is male, all male salaries. Right? So first we created a group. First we created a group team. When you create a group operation, when you apply group operation, it will create what? Inner bags team. Inner bags. So we got inner bag. Now we are applying sum operation, gender wise sum. Gender wise sum. Let's see how we are applying. CT, gender sum equal to for each gender by gender. This is our group name. Generate group as gender. Sum of es dot sal. We are not reading gender name. We are reading only salary as total. Now dump gender sum. Dump gender sum. So we are displaying on a console. Once we see output successfully, we are going to write it into HDFS file system. You can write output into HDFS file system too. Store gender sum into under root, under C family, under data directory. Under data directory, I want to store gender wise sum. So you can use gender wise sum operation. Okay, this is the output. Female 63,000, male total salaries are 45,000. So we are writing output into this location. Let's execute. And once it is successful, we can see the data output. Let's say here we can use grunt, and we can use under this location. We are going to see file, right? What is our file name? part-m-5 zeros. Yes or no? So use cat command. It will give output. Let me see. Once store completed, we are going to see this one. CT. So part-m is not available. First of all, let's go here, refresh here. Under data directory, gender wise sum, under data sum, part-r, because it is calculated sum operation, right? Yes or no? So any calculation, reducer comes into picture. Okay, so we got output. So this is store operation team. After storing, we are seeing HDFS location, file system data, output to result data. Then we can say developers. It may be Java developers, it may be Python developers, it may be Scala developer. Developers read this file, it contains gender-wise salaries. As part of Pig, we are writing processing. Okay. So next very important thing, multi-grouping operations team. Multi-grouping operations. Multi-grouping operations we are going to see later. What are multi? Yep. Let's continue aggregations team. In previous session, we seen total salaries gender-wise. So this is single group. So in this session, we are going to see multi-grouping aggregations team. Multi-grouping aggregations. Multi-grouping means we can take multiple columns as a groups. Example, let's say I want to take a department number wise as well as inside a department. Again, I want to calculate other group called gender. Let's say I have 3 departments team. 3 departments. I have 3 departments. Let's say 11, 12, 13. 11, 12, and 13. So we have 3 groups. Inside these groups, again, I have female and male. Female and male. Inside again, we have 2 groups sitting. So this is 11th department, this is 12th department, and this is 13th department. In this we have female and male, female and male, female and male. Female and male. So we want to calculate based on multiple groups. For this one, we use multi-grouping operations too. Multi-grouping operation. To make multiple fields as a tuple, so to perform multiple grouping aggregations, what we will do, make multiple fields as a one tuple. So group EMP by department number and gender. So make multiple groups as a tuple, group it by tuple. So we are grouping. Once we group multi-group, once we did multi-group team, then we apply multi-grouping operations. We apply multi-grouping operations. Let's say we have a EMP relation. Let's describe EMP. We have EMP relation. We described EMP. From this EMP relation, we are creating multi-grouping operation. We are creating multi-grouping operation. Okay. So describe GRP. So we got group is department number and gender. Okay. And in this employee, complete employee as a inner bag. Complete employee as a inner bag. Right? So let's perform multi-grouping operations. Observe result equal to for each GRP generate group dot department number. This is key. Group dot department number as department number. Group dot gender as gender. Sum of this is emp dot sal as total. Okay, press enter. So we are performing group wise total thing. Now dump result. So here we are instead of dump, let's say store this one into HDFS file system. Store this one into HDFS file system team. Multi-group operation result, we want to store it into HDFS file system. Once it's stored successfully, then you can print result team. I'm taking complete example for multi-grouping. So first we are loading employee relation. Then we are describing employee. We are creating a group based on 2 fields. Okay. Then describing group. Then we are performing multi-group operation. Then we are storing result into this location. Finally, we are going to display output of HDFS file, stored file. Let me excode this one. So department 11, female total salaries. Department 11, male total salaries. Department 12, female total salaries. Department 12, male total salaries. Department 13, total salaries. Department 13, total salaries. Department 14, total salaries. Okay. So in this way, we can calculate multi-grouping operations team. So understand, right? Yep. Let's understand co-group. See, my requirement is I have 3 relations: employee 1, employee 2, employee 3. I have 3 relations team. Requirement is I want to perform aggregation operations. Whatever aggregation operations we discussed, like sum, min, max, average, count. I want to perform these aggregation operations independently instead of union. I want to perform independently on each relation. That is my requirement. So what we can do? First, we will load all relations. Next one, we will perform grouping operations each relation wise. Yes or no? We will perform grouping operation each relation wise. Then we will perform aggregation operation each relation wise. Yes or no? So loading is mandatory. Without loading, we cannot perform aggregation operations. Okay. So first we load EMP1 relation, EMP2 relation, EMP3 relation. After that, we have to perform separate grouping operations for each relation, means 3 steps. Again, we have to apply aggregation operations each relation wise. Again, 3 steps, total 6 steps. So instead of doing multiple steps, Apache Pig introduced co-grouping. Co-group. So for multiple relations, you can create a co-group. You can create a co-group. Employee 1, gender. Employee 2, gender. Employee 3, gender. We are creating co-group. Then you can apply aggregation operation. So for each co-group, generate group as gender. Okay. Then performing emp1 dot salary, emp2 dot salary, emp3 dot salary. That's it. So it will perform some operation in each group wise. 2 steps. One is creating co-group, then performing aggregation operation co-group wise, group wise. Okay, let me execute this program team. First I am creating relation. Let me clear screen. So first up we are creating emp1 relation. Next describe emp1 relation. Okay. Next we are creating emp2 relation. Next we are creating emp2 relation. Describe emp2. Now next I am creating emp3. C3. emp3 column order is different. Yes or no? But we least bother about columns order because we are reading while performing aggregation operation. We are reading relation dot field name. Okay. So let's describe emp3. Okay. Now prepare a co-group. 1 minute, we got an error. Co-group equal to emp1 by gender, emp2 by gender, emp3 by gender. emp3 by gender. Yeah, now it is working. So here emp3 by gender. So describe co-group. Observe. See, group is emp1 and its inner bag, emp2, its inner bag, emp3, its inner bag. So all groups we have separate inner bags. Now perform aggregation operation on individual co-group wise. Then store this result in a HDFS file system. Then finally display the result. So it is processing team. Let's wait. Now let's execute output. So we got individual group wise. Observing. So this is EMP1, female, male. EMP2, there are no females. EMP3, female and male. We got output, right? Understand, right thing? Did you understand cogroup? Advantage of cogroup? So instead of performing aggregation operations, each relation wise, you can perform aggregation operations on multiple groups at a time by using cogroup. It's very, very, very important operator. Now let's see writing and submitting pig scripts. Writing and submitting pig scripts. How can we write? How can we submit pig scripts? First important point, thing, in all previous sessions, we written individual queries in a pig environment. Yes or no? Individual queries in a pig environment. The problem with the previous one is we have to write statement by statement. So instead of that, we can write all statements in a one file. You can submit that file to pig. You can submit that file to pig environment team. We can write all statements. In a one file. Then we can submit that file to pig environment. So here thing, we create a file by using cat. We can create file by using vi. We can create file by using nano editor. This extension is optional. You can take any extension. It is not mandatory. Extension should be .pig. You can take emp.srinivas, emp.cfamily, emp.txt, emp.xyz. Extension is optional. Okay. Then you can write all statements. So in this, what I am doing, I'm loading 3 relations team. I'm creating 3 relations. Relation 1, EMP1. Okay. So EMP1 relation team. Next, EMP2 relation. EMP3 relation. EMP3 relation. Next one. So from EMP, what I'm doing, I'm changing fields order thing. I'm storing in same relation. Fields order I'm changing. Let me change this one. Okay, I'm changing fields order thing. Next, finally, I'm performing union operation, merging employee 1 relation, employee 2 relation, employee 3 relation. Then finally, I'm displaying this relation thing. I'm displaying this relation on a console. Okay, this is my pig scripts. Understanding, we are writing, no need to write in a grunt cell. Come out from grunt cell. Clear screen. Control C means quit. Okay, now I am writing nano emp pig. Nano emp.pig team. So here I'm writing all these statements. I'm writing all these statements instead of writing single statements. We are writing all statements. Control X Y to save and quit from nano prompt. Once it is saved, first one thing. First step one, writing pig script. Writing pig script. Writing pig script too. Step 2. Submitting pig script. Submitting pig script. Writing pig script and submitting pig script. So here we are using pig is a command. Pig is a command team to submit. Pig is a command to start as well as pig is a command to run pig scripts. So understand this one. Here we have different ways. We have different ways to submit pig script. Submit pig script team. We have different ways to submit a pig script. First, way one. Using pig command. Okay. Using pig command, we are submitting. So let me take this pig command and try to execute this pig command. Pig emp.pig. Press enter. This pig command reads pig script and executes that script. Whatever the statements presented in that script by script, line by line, it will execute. If there is any dump command, it will display output. If there is any store command, it will write output into HDFS file system. After this, what will happen? Observing. Pig command executes line by line of each pig script. Let's wait. After completing, I will continue. So we got output. Successfully, we got output. Superb. Successfully, we got an output. So it displayed output. But problem, if you observe, after executing, it come out from pig prompt. Yes or no? It is not entered into pig prompt. It read pig script, executed all statements. It read pig script, it executed all statements. Then after completing, again it come out from pixel. See, it is come out from pixel. It is entered into our Linux prompt. Yes or no? First important point. Note 1. Relation alias not available in grunt cell. We can also execute pig scripts in way to we can also execute scripts from grunt cell. In this way to again we have two using execc command. Let me open our pig scripts or pig operators. Did you remember these pig operators? While explaining pig operators, I explained to run pig scripts. We can use pig command, we can use execc command, we can use run command. To run pig scripts, we can use execc command, we can use run command, we can use pig command. Did you remember, Tim? Yep. So we completed running pig scripts using pig command. We are now running pig scripts using execc command, Tim. Okay, execc command. First option in way to using exec command in a pig grunt cell team. Okay, so emp.pig. Okay, let's see. Clear the screen. See, where is our pig script? ls pwd. We are in same location, so we are starting grunt cell in same location. Pig. We are starting pig in a same location. Clear the screen. Now team, I'm using exec. File name is emp.pig. If it is different location, specify complete path. Exec command reads a pig script and executes line by line, displays output, then control enter into grunt cell. So we are running in grunt cell. But after executing all pig script statements, control still presented in grunt cell. After that, we are going to see the difference between previous one and this one. Previous pig command and exec command is pig command we can execute outside of grunt cell. Exec command we execute inside a grunt cell. First one. So we got output. But problem is inside a pig, how many relations we created, team? Inside a pig script, how many relations we created? emp1, emp2, emp3, e relation. When I say describe emp1, it is saying, Srinivas, what is emp1? When I type emp2, it is saying, Srinivas, what is emp2? When I type emp3, it is giving, Srinivas, what is emp3? When I type E, it is giving, what is E? It means once a pig script is completed, inside a pig script, whatever relations you created, right, we will lose that relations. Inside a pig script, whatever relations we created, we will lose that relations when you use exec. Understand, team? One important to note, still relation alias are not available in grunt cell. Clear? So if you want to relations in a grunt cell, B using run command, running pig scripts, running pig scripts, in a grunt cell using run command. So run emp dot pig. So let me execute the same thing in a grunt cell. See, previously we did not see any relation. Once you use run emp.pig script, it will execute pig script. Inside a pig script, it will read each line and execute that line. And finally, relations it will store inside a grunt cell. It will store relations inside a grunt cell. See, we are seeing output, right? Yes or no? We are seeing output. After this, I am doing describe emp1. Super. We got emp1 relation. Describe emp2. We got relation. Describe emp3. We got relation. Describe E. We got relation. That's the beauty of run command thing. Right? So important to notice. Now relations are available. Okay, let me copy this one. So now we are able to see relations. Understand, right, team? The difference between run command, exec command, pig command. Did you understand writing, submitting pig scripts? Okay. That's it for writing and submitting pig scripts. Let's start thing. So in this session, we are going to discuss giants in pig. So first, why giants? Why giants? Why giants? So main giant purpose is to get data from more than one relation, more than one relation in Apache Pig. We have two relations team. One relation is EMP relation. EMP relation contains this data team, and another relation is DEPT relation. DEPT contains this data. So we have two relations. To get the data from more than two relations, we use giant setting. First, let me start pig. Then load two relations. Team. So first relation, I'm loading EMP relation. So let's say emp1.csv. and EMP1 relation or EMP relation. Next one, DEPT relation equal to load under root under C family under data directory. We have a DEPT relation using pig storage, and delimiter of that file is comma separated, and as DNO integer comma department name char array comma department location, D location equal to char array. That's it. So we have another relation. 1 minute. DEPT equal to load under root under C family under data directory DEPT using pig storage okay, yeah, sorry team. So here we have to give colon into colon department number colon int dname colon char array d location colon char array. Okay, now it's working fine. Still it is giving error. Let me think. The built-in pig storage. Now it is working. So we created two relations. One relation is EMP relation and another relation we created DEPT relation. Okay. So we have different types of joins too. We have different types of joins. In Apache Pig. So we have inner join. First one we have inner join. Next one we have left outer join. And next we have right outer join. Right outer join. And next we have full outer join. Full outer join. So we have 4 joins: inner join, left outer join, right outer join, full outer join. We have 4 joins. So coming to inner join team. Inner join we implement based on common column of both relations. We implement inner join based on common column of both relations. So EMP1 has department number, DEPT has department number. So it will return common values based on common column. So here common column is in both EMP and DEPT. So here department number. So if both are matched, we will get record. So here 11th department is matched, 12th department is matched, 13th department is matched, 14th is not matched. So we get only match records. Inner join means we get only match records from both relations. We get only matched records from both relations. Let's implement inner join team. Let's implement inner join. So I'm implementing inner join now. So join EMP1 by department number, DEPT by department number. So error. Sorry, here not EMP1, EMP. Now dump inner join. We get output. Dump inner join. Let's see the output team. So we have match records only 2. Sorry, 11th, 12th department, 13th. 14th and 15th departments are not matched. We get only match records output team. Okay, let's see. Let's see the output. Let's see team. We got only match records. Let's copy the output and verify. Say, so 102 department number 11. So department 11 both are matched. So 101 employee department 11 department 11. 104 employee department number 12. 103 employee 12. 106 employee 13 and 13. 105 employee 13 and 13. Understand right? So only match records we got. 14th record is not matched, we did not get. 15th record is not matched, we did not get. Only we got match records. Inner join returns only matched records team. Clear? Now let's understand left outer join. So let's take both the records team. Both the records. When we implement this one, when we implement a left outer join, so left outer join equal to join EMP by department number, left outer comma DEPT by department number. When we use this syntax, what will happen? So first one, EMP is a left side relation, right side relation is DEPT. In this left outer join syntax, left relation is EMP, right relation is DEPT. We are applying left outer join. First we will get all match records. 101 matched. 101 matched. I'm doing analysis team. So 11th is matched. And next one, 102 is matched. For 102 also, matched record is this one. Yes or no? Department is matched. Next, 103. For 103, 12th record also matched. So 12th department also matched. Yes or no? Next one team. So 104 employee, 12th department is matched with left right side table. Okay. So we get this matched record. Then this one 105 also 13th department is matched. Okay. So 13th department is matched team. We will get 13th record. Next 106 also 13th department is matched. 106 also 13th department is matched. So this is 13th department. And coming to left side, there is a record 14th department. Corresponding 14th department is not available in right side table. Yes or no? So this is non-matched records. Non-matched record of left side, not matched with the department number, department name, location. For that we get empty. First one, matched records of both the table, non-matched records of left side table. For non-matched records of right side table values, we get empty. So this is our output team. This is our analysis. Let's see practically. Let's see practicality. Let's use grunt dump left outer join. So let's say take this one and execute this one in grunt cell. Dump left outer join. See the output. Yep. Observing only this 14th we got null values from left side, right side table. Left side table we got values, but right side we got empty. Yes or no? Now right outer join. Now let's understand right outer join. So let's understand right outer join. Same thing, only we are using right outer join. So this is instead of left, we are using right outer join. So right outer join. Then we use dump right outer join. When we say dump right outer join, first we get all match records. Okay, so these are all match records. Next we get non-matched record of right side. Non-matched record of right side team. For this non-matched records of right side, there is no employee number, there is no employee name, there is no salary, there is no gender, there is no department number. So for right side we get empty. So this is called right outer join. So first we get match records of both the relations. Next one, non-matched record of right side table. Sorry, right side relation. That's a thing. Let's see the practical. Let's see practical. So I'm using right outer join, right outer. They given simple operators, right outer. No need to write complex. They given already operators, right outer join, dump right outer join. See output team. Yeah. So first we got all match records. Next we got non-match record of right side relation. Okay. So that's it for right outer join. Now let's understand full outer join. It is a combination of left outer plus right outer join. It is a combination of left outer and right outer join. So here we get what? So first we get full outer join. When we say full outer join, full outer, then first we get all match records. Matched. First we get matched record of all, non-matched record of left side, non-matched of left side, and next one non-matched of right side, too. Non-matched of right side. So non-matched of right side means this is the record. So we get all records. We get all records. So first we get match records. Next we get non-match records of left side. Next we get right side non-match records. This is full outer join. Okay, let me execute this example. Clear screen. Then use full outer. Full outer join. Dump full outer join. Dump full outer join. Yep. So same way, first one, all match records. Next one, non-match record of left side. Next one, non-match record of right side. So we get both of it. So that's it for joins in Apache team.